True.
A. An increase in the temperature of a given mass
An increase in the temperature of a given mass,
of a gas
given mass of a gas
increases
increases
the number of gas molecules.
the number of gas molecules.
B.
B.
An increase in the temperature of the gas
An increase in the temperature of the gas
does not affect the kinetic energy.
does not affect the kinetic energy. C.
C. An increase in the pressure of the gas
An increase in the pressure of the gas
is proportional to the increase in volume.
is proportional to the increase in volume. D.
D. A decrease in the pressure of the gas
A decrease in a pressure of a gas
is proportional to the increase in volume.
in proportional to the increase in volume. Feel free to pause the video and give it a trial. Okay, let's go. The first one option says, okay, which of the following statements is true? The first option is an increase in the temperature of a given mass of a gas increases the number of gas molecules. Wrong. An increase in temperature cannot increase the number of gas molecules. Second option, an increase in the temperature of the gas does not affect the kinetic energy. It does. So this statement is wrong. An increase in temperature of the gas will definitely affect the kinetic energy. C, an increase in the pressure of the gas is proportional to the increase in volume. Wrong. According to Boyle's law, which states that the volume of a fixed mass of gas is inversely proportional to the pressure, provided that temperature remains constant. So wherever there's increase in pressure, there will be decrease in the volume. So let's see the last option, which says a decrease in the pressure of a gas is proportional to the increase in volume. Correct. This has proved Boyle's law, which I gave this graphical representation the other time. I said the higher the volume, the higher the pressure, the lower the volume. The lower the pressure, the higher the volume. P4, V4, P5, V5. So from this representation, you can see that our P1, when the value of P1 increases, the value of V1 decreases. When P2 decreases, V2 increases. So the higher the pressure, the lower the volume. The lower the volume, the higher the pressure, and vice versa. So the right answer is D, which proves Boyle's law. So let's move to the next question. Question 2. 1982.
Question 3.
Question 3.
It says the pressure on 100 centimeter cube.
The pressure on 100 centimeter cube
Of oxygen.
Of oxygen
Gas.
Of oxygen gas
at 35 degrees Celsius.
At 35 degrees Celsius.
Is 750
millimeter mercury.
Yeah, full stop. It says what will be the volume of the gas?
What will be the volume of the gas
if the pressure is increased?
If the pressure is increased
to 1000
millimeter mercury
without changing the temperature.
Without changing the temperature. So the first thing we do here is to analyze the question, get to know which law this question is talking about. So it says the pressure on 100 centimeter cube of oxygen gas at 35 degrees Celsius is 750 millimeter mercury. What will be the volume of the gas if the pressure is increased to 1000 millimeter mercury without changing the temperature? Even without writing out the variables, this clearly states the Boyle's law, because in the Boyle's law, the temperature remains constant. And a given temperature is given here, 35 degrees Celsius. At the end, it says without changing the temperature, which variably says that the temperature was constant. So the next step is to write out our variables. Since we know the law is talking about Boyle's law, so write out our formula, which is P1 V1 is equal to P2 V2. But in the case whereby from the question you can't deduce the formula to use or the law it's talking about, the next thing you do is to write out some variables. So what are the variables? We have 100 centimeter cube, which is the volume. That would be our V1. V1 is 100 centimeter cube of oxygen gas at 35 degrees Celsius. Though we don't need the temperature, but let's just write it out. We have our temperature to be 35 degrees Celsius. Is 760 millimeter mercury. From our understanding, any unit with millimeter mercury is talking about pressure. So our first pressure is 750 millimeter mercury. What will be the volume? So you are looking for the volume, V2. V2 is not given. If the pressure is increased to 1000 millimeter mercury, P2 is equal to 1000 millimeter mercury. Even from this, to confirm if your answer is correct, from this illustration here that says the higher the pressure, the lower the volume. That means if the pressure was increased from 750 millimeter mercury to 1000 millimeter mercury, definitely the volume will reduce from 100 centimeter cube to a lower centimeter cube, probably 75 centimeter cube. But let's give it a try first. So write out our formula down again. P1 V1 is equal to P2 V2. What we're looking for is our V2. We make V2 is subject to the formula, which becomes V2 is equal to P1 V1 over P2, which is equal to our P1 is 750 times our V1 is 100 over, 100 over our P2, which is 1000. We can use two methods to solve this. We can either write it out, calculate it out in full. 750 times 100 will give us 750,000. 750,000 divided by 1000. 75 over 1000. Over 1000 to give us cancel to give us 75 centimeter cube. Or another alternative way, you just cancel out the zero effect. You have 0 here, cancel. You are also left with 75 centimeter cube. So now in cases whereby you are giving your volume, if V1 is given to be in the dm cube, that is the centimeter cube, then your V2 answer must be in dm cube. But because our volume was given to us in centimeter cube, that means the final volume we just looked for must be in centimeter cube. So the answer is 75 centimeter cube. Let's move to the next question. Question 30.
It says 28.8 centimeter cube of nitrogen.
28.8 centimeter cube of nitrogen
At 15 degrees Celsius.
At 15 degrees Celsius.
Is cooled at 0 degrees Celsius.
Is cooled at 0 degrees Celsius.
At constant pressure.
At constant pressure.
What is the new volume of nitrogen?
What is the new volume of nitrogen? Solution. You can feel free to pause the video and give it a trial. To proceed with the question, 28.8 centimeter cube of nitrogen at 15 degrees Celsius is cooled at 0 degrees Celsius at constant pressure. What is the new volume of nitrogen? From the question, I'm able to deduce that this is talking about Charles' law because it's talking of constant pressure. And Charles' law states that the volume of a phase mass of gas is directly proportional to the pressure, provided the temperature, provided the pressure remains constant. In Charles' law, pressure is constant, but in Boyle's law, temperature is constant. So to go with this, we all know that it is Charles' law, which is V1 T1 is equal to V2 T2. But in a situation whereby you don't know the formula to use, the next thing you do is write out your variables. So we have our V1 to be 28.8 centimeter cube. Our V2 is what we don't know, new volume, unknown. Our T1 is 15 degrees Celsius and our T2 is 0 degrees Celsius. So one thing you should note again, while calculating gas laws, our temperature has to be in Kelvin, and the standard temperature that I stated before is 273 Kelvin. And the unit of conversion from degrees Celsius to Kelvin is simply degrees Celsius plus 273 to give us our final answer. So to do with this, what we need to do is to convert our degrees Celsius to temperature by just simply adding 273 plus 273. Mind you, I didn't tamper with the pressure when we were calculating this. We only deal with temperature, converting degrees Celsius to Kelvin. 15 degrees Celsius to Kelvin becomes 15 plus 273, which is 288 Kelvin. And 0 plus 273 gives us 273 Kelvin. Let's proceed out. V1 over T1 is equal to V2 over T2, making V2 subject to the formula. Therefore, V2 is, when you cross multiply, V2 becomes V1 T2 over T1. V2 is, what is our V1? Our V1 is 28.8. 28.8 times our T2, 273. 273 divided by our T1, 288. 288 to give us 28.8 times 273, which is 7,862.4 divided by 288. Divided by 288. So the final answer is 27.3 centimeter cube. When you're talking about temperature, we use Kelvin. When you're talking about pressure, we use millimeter mercury. And for volume, we use centimeter cube. So the final answer is 27.3 centimeter cube. Having done with that, so kindly check your answer, cross-check to see if you got the answer. And if you did, thumbs up. Question 4.
For the year 1979.
1979.
Question 45.
Question 45.
It says a gas occupies 30.0 dm cube.
A gas occupies 30.0 dm cube
At STP.
at STP.
What volume would it occupy?
What volume will it occupy?
At 91 degrees Celsius.
It's 91 degrees Celsius.
And 380.
380 millimeter mercury. Okay, a gas occupies 30.0 dm cube at STP. What volume will it occupy at 91 degrees Celsius and 380 millimeter mercury? You don't have to stress yourself on this question. This is just talking about the general gas equation that we did today. P1 V1 is equal to T1 over T1 is equal to P2 V2 over T2. Mind you, the question states at STP. STP means standard temperature and pressure. And I gave the values to be T is equal to 273 Kelvin and P is equal to 760 millimeter mercury. So this becomes our T1, T2, P2. As a gas occupies at STP, what volume will it occupy at 91 degrees Celsius at? So this should be T1, P1. Because the question states that a gas occupies 30.0 dm cube at STP.